Hi, I'm David, and I'm going to try to go over a few things about polynomials that we've been learning a lot. So let's take question A right here, question A, and we're looking for the degree, the leading coefficient, and the constant. So if you take A, the degree is the highest exponent, the largest exponent. I see an exponent of 3, 2, there's a 1 there, and make sure you understand there's a hidden x to the 0. There's always an invisible 1 on on a variable for an exponent if it's not listed. And then there's this hidden x to the 0. Just a cool little feature I thought I'd share. So what's the degree of this one? 3, the highest exponent. When you find the degree, look to the same term. The leading coefficient is the number in front. The leading coefficient is the number in front. And there's an imaginary or an invisible 1 there. There's an invisible 1. So the leading coefficient is 1. And where you see the last number, where you see the number with no x on it, that's called the constant. That's your y-intercept, because if x is 0, that's all you'd have left. So our constant in this one is 8. Okay, let's scan it. Let's scan B. Scanning all the terms. All right, I've scanned them. Highest exponent is right here. 4. When you find the highest exponent, look to the number in front. That's the coefficient, and that's specifically the leading coefficient. The last number on that polynomial is a 1, and it is a constant as long as there's no x on it. Cool. Same thing with this last one down here at the bottom, C. Scan it. Scan it. Uh-oh. It's not written in proper form. Standard form says have the highest exponent there. That way you don't get confused with the phrase leading coefficient, because you might think that 13.2 is the leading coefficient, and it is not. If I was to rewrite this in proper standard form, that means getting the exponents in descending order, 4, 3, 1, technically 0 right there, right? All right, now we can answer the questions. The degree is 4. The leading coefficient is right there, 3. And the constant hasn't really changed. It's still -4. All right, let's take a look at another one. So one of these polynomial equations, A, B, C, or D, has the zeros. That's from my favorite question, right? What makes 0, I'll write it as an acronym right there, okay, has the zeros or the roots, remember those are the same words, or the x-intercepts, don't forget, okay, has the intercepts -2, 3/4, and 5. So that means there's a binomials out there, 3 binomials out there, binomial, two-term expressions, okay? And so there's 3 of them that say what makes 0 is -2, 3/4, and 5. Let's just take a look at A right here. If I asked what makes 0 with x -2, I'm hoping you can see that a +2 for x would make 0. So this one would have a 0 or an x-intercept or a root at 2. At 2, 0 specifically, because it made 0. X plus 5 would have a 0 at -5. Now you might be thinking, hey, it's just simply the opposite symbol on these numbers. Yeah, there is a way to do that where it is the opposite of the number you see in there. But I beg you to take your time when it gets a little bit more complicated. For instance, if you think a -4 is going to make 0 out of that one, it isn't. That's the curveball. If you want to know what x makes 0 with the binomial 3x plus 4, then you've got to either hold an algebra equation in your head, 3x plus 4 equals 0, and do the algebra steps. Now, I think if you're in advanced algebra or pre-calc or calc, the question of what makes 0 for a two-stepper might be within your grasp. All I ask you to do is hold 2 numbers, one in the numerator and one in denominator. Because if you were to subtract 4 on both sides here, that's going to be your numerator in a second. And then if you were to divide by 3 for the next step, divide by 3, right? Cool. Then guess what? You found that there's a 0 at negative 4 over 3. Now, don't think you have to calculate that. We don't do that in math. That's what we're doing. We're holding this fraction in our head. All right, you ready? Which one of these, A, B, C, or D, has it? And if you look way down here, negative 2 on D. Watch this. 5 there. Okay, you ready? Can you hold a fraction in your head? Add 3. Divide by 4. Yeah, you're doing two-step algebra in your head now. Isn't that cool? All right, let's take a look at another one. Let's take a look at another one. Let me clear my screen there. Okay, this one's simply asking, what are the x in... Oh, excuse me. This graph of a polynomial has x-intercepts at 2 values. What are they? So they're just asking, what makes 0 again, aren't they? What makes 0 with the first binomial? Well, if you think opposite, that's fine, but make sure it really makes 0. And that's 4. And the next one would be negative 3.